So I get the honors of doing this 3 p.m. slot. I keep doing these 3 p.m. slots when everybody's nice and tired after lunch. But today I'm going to talk to you about what we did at where I work now at Snyk, which we'll come on to. But this is about our journey, which has been two and a half years in the making, around how we've worked with 300 internal engineers to build out our platform engineering capabilities, and what our developer experience teams have been doing there as well. So here we have somebody, our lovely engineer. Here's the early days. Things are pretty simple now. They don't have a lot to reason about. As you can see here, they've got a few tools that they need to be aware of. This is probably more like your 99% engineer, which is like, you know, the masses. Like, this is somebody who's probably a product engineer. She's thinking about shipping. Like, normally when you start a company, it's about your runway. You need to get features out. It's quite golden time in a lot of ways because there isn't a lot of cognitive load, and you can just push to main like you're just totally alive and not have to worry about anything else. And kind of have some semblance of these other things. I think I'm being quite generous here, by the way, by putting things like Grafana and monitoring in. I mean, I have worked at places where these things come later in the process and aren't even there kind of at the early start. But then as the company grows, things change quite rapidly. And I think this is a picture that we'll all understand. Oh my God. So like, yeah, so she now has to reason about a lot of things. And this is just like some of the kind of capabilities and tooling that are now in her sphere that she has to be aware of and have to reason about and use on a daily basis. As you can see, like when I started, say, 20 years ago, you know, I had the beauty of working more as a web developer to start with. So like things did feel a lot simpler then than they do now. And now we're asking engineers to reason about a lot and expose a lot to the engineers and expect them to cover a lot more ground than what they were used to. But not only that, there's also all the practices that go along with it too, and the kind of growing complexity in the systems as well. And so here we can see, like, we looked at the tooling before and some of the capabilities. Here are some of the other elements that are involved, right? Like things like there's increased coordination, there's more complexity in the tools, there's more things like alert fatigue, you know, test flakes, big problem, like broken Windows scenarios where we're just kind of saying, oh, you know, it's always been like that. Nobody really truly owns that. So therefore, it just gets worse and worse. Things degrade over time. And, you know, one of the things I want to call out here too, because it would be remiss at a SRE conference, is things like bad monitoring practices start to creep in. That's quite a common one I've seen, or performance challenges. And it's not because engineers want to do a bad job, but we're expecting all engineers to be expert at all things. And I think that is where we start to go a bit wrong. And we expect them to be good at all of these things as well, which, unless you've had a very diverse career, like myself, where I've worked in all types of engineering roles, it's very difficult to have much expertise at all of these things. And so you can see here, she is losing her mind. She's getting really annoyed and frustrated. And this is what I call the death by 1,000 cuts. Like, she's probably thinking about looking for a new job by this point. So we are no longer experts enough to cover all things at this kind of scale, and we can't hold the system in our heads anymore. And so today, what I want to talk to you about is 3 parts. So first of all, I'm going to cover how platform engineering accelerates the need for DX, developer experience. Some of the models, the principles and practices that I like to use and have employed in the last couple of companies that I've been in. And then lastly, a case study of how I've put these things into practice at Snyk. So I do love research, but I love more to see how to apply that research in practice. And so that's what we'll deep dive into in the last section. So I'm Crystal Hirschorn. I'm a Senior Director of Engineering at Snyk. Like I said, I've been doing this for 20 years, mostly as a practitioner. So I was a principal engineer before moving into full-time management. Worked in all kinds of roles. Like I said, I started off web developer, front-end developer, back-end developer, operations, platform. I did the whole lot. So first of all, let's talk about platform engineering and how that's a catalyst for developer experience. So, and some of you might have seen me speak at QCon, so I do have a few slides in here, if you saw that are a bit of a repeat. But I talked there about platform engineering too, and I want to use the same content in some cases because it's some of the best things that I've seen out there when doing the research and just doing lots of reading about the topics. And this guy here, he wrote an excellent blog post, which is linked down here at the bottom, and hopefully we'll share the slides afterwards. And I want to read out this quote. So he says, "A digital platform is a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. Autonomous delivery teams can make use of platform to deliver products at a higher pace with reduced coordination." So very, very good definition, encapsulation of what we mean when we talk about platform engineering. So when we approach this kind of idea of like building out something like an internal platform offering at Snyk, there are a few models already out there that kind of help us reason about this and think about this. I found this model when I was doing, again, research for this talk, which I think is really good. And again, there's lots of things that I've just pulled from different things that I've read, by the way, so I tend to link to it if you want to go and read it later. But I think this is quite a good one as well, like in terms of thinking about the kind of layers, the stack that we have to contend with, particularly from an infrastructure point of view. But then thinking about how a lot of the things that are here are exposed to all the engineers that are in our company, and whether, you know, where the right balance is for that kind of thing. Like, what's the APIs that we should expose to them? What should we expect them to be able to reason about? I'm going to give you a little sneak preview. So this was our layers model that we used at Snyk to build out our own internal developer and runtime platform. And as you can see here, we've got like a 6-layer model, kind of a layer 0, but we also have down here like RBAC, backup, audit, cost management as our kind of foundational layer, cloud provider, account, and IAMs. Then on top of that, networking, then our clusters, then our APIs. Our internal platform is called Polaris, that's why it says Polaris APIs. And then on top of that are Snyk applications and services that run there. And I'll go into more depth about this in the third section. But this was like a good foundational way of thinking about how are we going to build this. And it was the first frame of reference that we had before we built out a very quite complex reference architecture that then allowed us to build out the platform. One thing that was interesting to me, so like Gartner, who knows about Gartner? Probably everybody. But like platform engineering is really like early on. It feels like, I don't know, probably a lot of people in this room, if you're as old as me, it doesn't feel like it's that early. Like it feels like platform engineering's been around a long time. But in terms of industry adoption and what we're seeing, they think it's fairly early on. Like it's all the way down here. So yeah, we have a lot of kind of journey yet to go, basically. And so I guess one of the things I'd say is the API surface has just got way too broad, incredibly broad for engineers to reason about on a day-to-day basis. So how can we kind of overcome that challenge? And one of the things that I really like as well, because I'm talking about APIs and services and boundaries, but we're still working inside a socio-technical set of systems. And so I really like this quote from Matthew Skelton, again, team topologies, DevOps topologies. I'm sure everybody's aware of it, but he wrote this great tweet, which was like, what if the most important part of platform engineering is maintaining a high-quality wiki with proven empathic patterns for stream-aligned teams to follow? And like I say, in my own experience, one of the things that I do see that's really challenging to keep up to date is things like documentation. Like you do want engineers to follow the patterns that you're providing in your platform, but sometimes these things can be forgotten about, and they're almost one of the most fundamental aspects of offering an internal platform like this. So I want to go into the second section, which is more around like what models, practices, and principles have we used and kind of guided me over the last couple of companies that I worked at in terms of trying to actually make these things really successful. So a book that I read about 2 years ago has greatly influenced how I think now, and I wanted to throw it up here. because I like sharing. This is one thing I really like doing through my talks, is like not only the experience, but like things that I've found which really fundamentally changed the way I think. And this book is called How to Measure Anything. And it says, Finding the Intangibles in Business. Sounds really dry. But if you read it, stick with it. It's an amazing book. And it can be a little bit scary because sometimes I talk about statistics quite a bit, but he breaks it down in a way that I think is not too challenging for anyone to understand. But for me, it was like just a way of like thinking like, yes, actually anything can be measured if we want to measure it. We always say to ourselves, oh, you can't measure that. It's too vague, or how would we ever get clarity around that? So I want to call out a quote from him just to kind of ground ourselves in and why it's important to look at this. So he says, if you have a lot of uncertainty now, you don't need much data to reduce uncertainty significantly. But if you already have a lot of certainty, you'll need a lot more data to reduce the uncertainty significantly. So he says, in other words, if you know almost nothing, almost anything will tell you something. And I think that's a great quote. So this is by Douglas W. Hubbard, who wrote the book. And so we started to think about like what kind of models could we use in our own systems, and thinking about like, you know, where's the inefficiencies, where's the friction, and what we might be able to do about that, and how to quantify things like that, especially when it feels vague and intangible. And it's about reducing uncertainty and reducing risk. These are the two kind of things that this book is really grounded in. And so, yeah, so this, I'm going to touch on a couple of examples of models that we used, that we are using right now at Snyk. So the first one I'm going to talk about is the CI/CD cost of delay model. So if you've been around in the industry as long as I have, I was kind of cast in the days of Lean and XP and like true Agile. And so for me, like I find this is like really fundamental in the way that I think about the work that we do, and what we're trying to produce. And so we came up with this model at Snyk. And so this is an actual screenshot from, it is just a spreadsheet after all, but it was incredibly powerful for us as engineers, particularly engineering leaders, product leaders, but also our execs above us. Like we could inform them, we could use this data to kind of say like, hey, look at this. Like we have 300 developers. They ship roughly 3 PRs a week. They, that goes back and forth 3 times on a PR review. Their, average salary is 125 grand a year. And this is how much we spend on CI. This is how much we merge. This is how many PRs we build. This is what it is over a week. And then like below the line where you can't see it, we actually have a way of running those calculations. And the cool thing that we did was we said, okay, the build takes 60 minutes right now, because we have just to describe a little bit, we have a monolithic architecture still at Snyk. We are breaking it out, yes, I know, but it's still there. And so like to run things through the monolith was taking about an hour when I first joined my company. And then we're like, what would happen if we could make it 20 minutes? Plug the number in, and it's massive. It's like over the course of a year, it's going to save us $6 million. Holy shit. Then you can go to management and be like, this is where we should be spending our time. And stuff like this really excites me, right? Because it's like, finally I can go to management and say, this is where we need to invest. Like this is where we're wasting a lot of our time and inefficiency. And then it's like, well, what happens if we keep decreasing? And eventually you're going to get to like diminishing returns, obviously. But it was a really powerful model. And it didn't take us that long to come up with this. And we have Slack channels, and we still try to keep on top of this from time to time to say, okay, what's the lead time to deploy, and like seeing like how we can bring that back further and further. So that's one model. I say you can do it. It would only take you a couple of hours to throw something like this together. I'm happy to share something like this too. The other thing that we haven't quite tackled yet, but we're hoping to. I've got my 2 lovely SREs here in the front, who are helping me with this. But like, so something else that feels quite intangible is like, okay, we talk about the lead time to deploy something, but what about let's look at the other end of the spectrum. Like, what does it cost us when we have an incident? because I don't think anybody has, at least I haven't seen a model that really quantifies this yet, but I feel like it's within our grasp. And so I just want to show here, we use fire hydrant, obviously, that's why it's showing. We had a bad week. As you can see, we had a Sev 1, a Sev 2, two Sev 2s, a Sev 3, and we have Sev 4s as well, which are kind of like not as important, kind of maybe in hours if you want to get it solved. But like, yeah, it's like that was a pretty bad period of time for us, and it'd be interesting to go back and say, well, what do we think was the cost to us as a company? And I feel like this is something that's within our grasp, just like the other model. And so I was thinking about, like, what will we capture? And so we do have things like SLOs in some places. It's not consistently across the board, because I want to be transparent, and I want to be like, I don't want to stand up here and be like, oh, it's all rose-tinted glasses where I work and it's perfect. Well, thank you. But like, we do have SLOs, so that's part of the story that can start to tell us something about user impact. But I don't think it's the whole story. And so I started to think about, like, what can we do? And so I thought, what might it capture? So like the average ARR of a customer, the downtime, like impact on trust and credibility, and maybe giving that some sort of score, the lost development time and blocking of prod changes, the cross-departmental impact, which is something that I think is harder to probably quantify, but something worth doing, because it's usually not just R&D that's affected by incidents. And then staff salaries, like we had in the last model. And I think, like, what else? What else? Any other ideas about what we might put in there? Silence. Retention. What'd you say? Retention. Retention, yeah, burnout. Yeah, we could look at things like that too. For sure. Cool. And then we just need to find where the friction exists. So I'm going to talk a little bit about, like, so that was the models, cool. And there's probably a lot more for us to explore in that space, but just trying to get your thought process going around that and what you can do in your own companies. And so I wanted to talk a little bit around, like, the way humans work. And I'll try and go through this quite rapidly because I know I've only got 10 minutes left. So there is another great resource, Change the way that I fundamentally think about socio-technical systems and the way that humans work. And it's this Varieties of Human Work by Steve Shork. He's really big in the systems safety and human factors fields. And he talks about this, which is like, we imagine the way that work is done. There's a way that work is prescribed to us. There's work that we disclose, and there's the work that we actually do. Like, what is it actually like to do the work? And these things somewhat overlap, but some of it is very discrete and not observable, right? So it's like, how can we get around the fact that, we as platform builders, we probably do a lot of imagining of how the work is actually done by the engineer. So how do we overcome that challenge? And then there's another great talk by Dr. Laura McGuire. So she does a lot of, she's done a whole PhD on researching incidents. And she's gone to lots of big companies to do this, read thousands of pages of incident kind of Slack conversations and Zoom conversations. And she gave this excellent talk afterwards. It was called The Cost of Coordination, like how much is too many? Like how many people can you orchestrate and coordinate in an incident? And here was a great quote from her. It says, well, I know that there are a lot of differences between astronaut and mission controllers, software engineers. There's a fundamental basis about how humans work. So how cognitive work takes place when you're handling uncertainty, when you're under time pressure, when you're managing risk, and when you're coping with interactive failures, all of this under extraordinary time pressure. So again, another great talk to go and watch. But again, thinking about how do humans work and what's the cost of coordination. So just a couple quick things I'm going to run through. So pairing has been a big thing for us as well. We probably could get better at that. Particularly the embedding side of it. So I do think pairing is one thing, but I think embedding is like you're actually going to see how the work is done. So I have a developer experience team, SRE team, and trying to get them to do more embedding and having people come back towards our area would massively help in that, I think. Surveys and interviews, like, I think we're imagining a lot. How about you just go and ask them? They're engineers. They're like your friends. Like, what better customers to have than other engineers, right? So I do think there's a lot of, I'm not going to touch on this too much, but there is like also some guidance on how to do this well, because I think it can be done badly as well. And then things like sentiment scoring, like NPS scores. We haven't done this yet, but I would like to do this. But things like this, and I quite like this, like how's my programming? It would be great to have that kind of thing to say, like, you know, you're using my platform that we've developed, but like, what's the experience of it? You know, do you like it? Like, what things do you not like about it? Because people tend to have emotions about things that they're working with. And then one of the things that we did at Snyk, quite more or less successfully, and still working on it, is I don't really like scaled agile that much. A Spotify model left somewhat of things to be desired, but one of the things I thought was the best was the guilds idea. And while we don't have language guilds, because I think that's more like, and from experience, I'd say that's more of a interest group, probably, alignment. We have things like actual capabilities and practices. So we have testing, performance, and my favorite, incident response. And we just did a reboot of our guild. And so I threw that in there. That was like as of today. But here's our reboot. So our charter is to strengthen Snyk's ability to respond to, learn from, and prevent incidents. And we run that like a fractional agile scrum team, because we actually want to get shit done. Feedback loops, important, like in terms of like how long are these feedback loops getting, but also how can engineers get in touch with you? We have ask channels, we have office hours at Snyk. And like I said, like just getting on the ground and being with the engineers more is really important to try and learn about how they're using your systems instead of pretending like you understand. And then measurement. Again, I'm going to skip over this because I'm aware of my time. So let's jump into a little bit more depth around like what did we actually do at Snyk and what was the IDP like that we built, the internal developer platform, and the DevEx fundamentals that underpin that. Charity's going to present tomorrow. She's one of my heroes. This is how I feel about platforms and just maybe the work that we do. So operations is the constellation of your organizational memory, patterns, practices, habits, defaults, aspirations, expertise, tools, and everything else used to deliver business value to users. She's amazing. Go and see her tomorrow. I'm sure everybody is. And so what did we do at Snyk? So we serve millions of developers. If you don't know, we're a DevSecOps company. We build tools for developers to make them more secure. We had like one production environment as of about, say, maybe 18 months ago, and then we built an IDP, and now we have 18. And we're all over different regions, and more regions coming. We have lots of deployment options now too, which we didn't have before. We only had one multi-tenant environment. So now we have single-tenant, multi-tenant, back office, which runs back office services, and FedRAMP, which is our newest one. But before we got started, we, again, modeled like, what does this platform need to do, looking at things like distributing like the actual USP of Snyk, which is like our vulnerability database and the feed around that. But also like some things required batch deployment, some things are kind of continuous deployment, depending on the type of deployment option you're looking at. So we looked at it from two different angles. And then, as I showed earlier, this layers model was the underpinning of the IDP that we built. And if you're interested, this is all the tech that we use. My talk is not about tech, but as you can see, we use quite a lot of modern tooling in our platform. I think Teleport were downstairs as one of the one of the sponsors, and they've got a booth, but we are using Teleport. We specifically brought that in because we wanted least privilege and a software-defined perimeter for FedRAMP, but we're using it across all of our environments. So I have 4 teams in my area, so Cloud Platforms, SRE, Developer Experience, and Broker Team. They have these little labels underneath because they're using the team topologies model, which a lot of people are probably aware of, and which I've referenced here on the next slide. So if you want to go and read about that, there's a whole book around team topologies, but this is the way that I tend to think about things when I'm designing organizations, because that's what I do as a director now, rather than designing systems. And this is how I see the work breaking down. Like, if you think about these enabling teams like SRE and DevEx, this is how they should spend their time. It's not just building tools. It's all these other things that go along with it. So for us, like developer portals, I'm going to talk about two key things. I'm going to talk about Dora, some Dora things that we did, but also developer portals. And so like one of the things I love to talk about is Backstage. I think so we're in our second year of using Backstage, and I say like it hasn't quite reached its full potential, but it's coming, and I feel like it's I'm going to keep with it because I just think it's going to be such a powerful lever for us across the industry to use that. So this again is more like what I hope the in-state is going to be like. We have tried some hack days around like creating things like scorecards and tech insights. Bit harder to do than we thought it would be. But eventually, this is where we'd like to get to, is like developers across the company log in and they can see lots of things about their services. We can roll that up to execs. We can start having things like health reviews and service 360s and actually having some accountability at the top. And there's a huge ecosystem behind Backstage, so please go and check that out. Sorry, I'm going to move swiftly on. I saw some of you trying to screen. This is my last section. So I want to talk a little bit about Dora, because I think this is quite important. So I know that there's a few people that have talked about Dora already. So these wonderful folks, Nicole Forsgren, Dr. Nicole Forsgren, Jez Humble, and Jean Kim wrote this book. Everybody's probably read it. But we took that and put it in practice, because I think a lot of companies probably haven't. And we looked at tools out there. And I was a little bit reticent to use them because a lot of them were like, oh, well, your management team can see how many times this person ships code. And I'm like, that sounds like a tool to beat the engineers with. And so we wanted to keep away from that. And so what we did is we ended up looking at things like Circle CI, Argo CD, Kubernetes, and Jira, and just taking statistics from that and creating Looker dashboards. And that's what we did. So I wanted to show you what we did. So here we've got a couple. This is the pipeline success failure rate for our applications, and I should eventually do a whole talk on this because it's such an interesting topic. But like as you can see here, when we started to look at success and failure, we thought, ooh, if we show this to the engineers, they might get really pissed off. They might go, it doesn't fail 90% of the time, and they might start to argue with us. So we thought, okay, let's break it down just a little bit more. So there are things where we like cancel builds. And then we also have breakout graphs that actually show what type of failures are happening in the pipeline, because it's not just always one type of failure. And of course, success is success. And then what's the deployment count? This was over 2 months, over March and April this year. And that was showing that the red there is, I believe, our kind of monolithic application, which does fail a lot. And then we looked at like how could we compare different applications against each other as well. And then we only counted the first failure in the pipeline. So what's failing the most often, we can see at a glance. But one of the biggest things that we found, because we talk a lot about Dora and like lead time to change, actually one of the most painful things that we found is like how often it takes to get a PR reviewed. Or like, oh, Jira ping pong, like I don't know what the hell I'm building. And I thought that was a really good graph like to put in there, because people can talk a lot about like, oh, I shipped this code and then it took the build this long. Actually, the thing that was painful was getting somebody to actually approve and merge the PR in the first place. And then we did things like deployment counts and how successful that was. Registry, again, registry is our monolith versus any other application. So we can see quite a wide distance between them, which is good to actually see that visually. And then the lead time to change as well. Again, registry versus everything else. And you can start to see anomalous things in there, like why is it spiking, and start to ask really interesting questions about the data. The very last one I'm going to show is this one, which we came up with, which is a brand new one. So Dora doesn't have this one, but Dora was like a doorway into thinking about what are good metrics. And we came up with something called Pipeline Reliability Index, a PRI. And we kind of put this on like a scale that could be both negative and positive. And we said, okay, well, let's see how we can represent that. And we fiddled around with this one a lot. But as you can see, like it's quite interesting to see, okay, some of these things are succeeding more than they're failing, but some of these things are failing a lot more than they're succeeding. And it was really good to kind of visualize that on a graph. And so again, any guesses for the purple? It's our monolith that fails very often. My penultimate slide. So what we're trying to do here is create incentives, not mandates, for engineers, and trying to provide the visibility and the tooling into that through our platform, and give them the options to self-serve where we can as well. And that's really it. I think, yeah, let's just say in summary, so we talked about platform engineering and how that was a lever for us in DevEx and for the industry. I talked about some of the models, the principles, and the approaches that we used in terms of building out a great developer experience culture at Snyk. And then, like, what did we do? Like, how did we build that internal developer and runtime platform? And how did we bake those more DevEx and SRE principles within that as we built? It wasn't just the tooling, it was also the community and the practices along with it. And that's me. Thank you.